Hello students, in this video we are going to discuss finding the formula of a compound. This is in solid state. For this one we should recall some points. Lattice point, sharing and atom on average. This is a point we have to take. The lattice point is center of cube. Sometimes they will say body center. This is only one. It is shared by only one. That's why one is the average atom. Whereas face center, for a cube there are 6 faces. Each face has one center. So 6 face centers are there. And one face center is shared by 2 other. If we take one face like this, so here is ion. This ion is shared by one other only. That means 2 unit cells can share one face center position. So sharing is 1 by 2. On average 6 into 1 by 2 we have. Edge centers. There are 12 edge centers. So each edge center, let us suppose this is the edge. So the edge is shared by one more unit cell and one is kept above this one, another one is kept above this one. Thus 4 are sharing, each one shares 1 by 4. So we take 12 into 1 by 4. Now corners, how many corners are there? There are 8 corners. Each corner is shared by how many? 1. Here this is 1, 2, 3 and this is 4 and cube kept above this one and cube kept above this one, cube kept above this one, cube kept above this one. Thus 8 are sharing, each one sharing portion is 1 by 8. So 8 into 1 by 8 we are taking 8 into 1 by 8. One more point is octahedral for CCP, cubic close packing, hexagonal close packing, FCC arrangement. Let us take as 4. For example, I am saying FCC. FCC means 6 face centers and 8 corners are filled with this one. Atoms or ions. So 6 into 1 by 2 plus 8 into 1 by 8. So 3 plus 1. That means for FCC arrangement or HCP arrangement or CCP arrangement, deadly you take as 4. Now the next one is for tetrahedral void. If FCC arrangement is taken as 4, you know tetrahedral voids equal to 2 times the atoms. Here octahedral voids are equal to 1 time the atoms. That's why for tetrahedral void you take 2 into 8. For octahedral void you take 1 into 4. Because for FCC we are taking 4. Double the number of atoms. Here equal to number of atoms. By keeping in mind these values we are able to solve. Now some more points are there. Now the some more points are 1. They are saying A occupy face center, but A atoms are removed along one axis, one direction or one axis. Thus they will give the hint. Now there are 3 axes X, Y, Z. Now there are 6 face centers we have by 3 directions, 3 axes. So each axis has 2 face centers. So here 2 face center, here 2 face center, here 2 face center. Now they give what? Remove face centers along one direction. Then this one become, actually we expect what? 6 into 1 by 2. But this is wrong. Instead of this one we write 4 into 1 by 2 because 2 along one direction are removed. So this is the method taking. Another hint. The another hint is they will ask, so they will say B is occupying corner. B is occupying the corner, but one position is removed. They are saying B occupy corner. Corner. B from one position missing. B is missing from one position. Now for corner what we write? 8 into 1 by 8. But they told what? One position missing. So instead of 8 we write 7 only. That's why better to write 7 into 1 by 8. We write what? 7 into 1 by 8. Similarly, one more. X occupy edge center. X occupy the edge center. They are saying X along one direction are removed. X along one direction are removed. Then what we write? Here actually there are three axes X, Y, Z. There are 12 edge centers. So 12 by 3 axes. So each axis has 4 edge centers. So we have to write 4 edge center, 4 edge center, 4 edge center. One along one direction are removed. Then actually we have to write 12 into 1 by 4. But because of missing, we write x into 8 into 1 by 4 only. This is a trick we have to follow. Similarly, one more application. They are saying P occupy tetrahedral void, but P is taken as alternate tetrahedral void. You know tetrahedral means 8. There are 8 are there. So 8 holes are there. Now alternate means one gap, another one gap, another one gap, another one. 1, 2, 3, 4, 5, 6, 7, 8. So then we write what? We don't write 8. Instead of this one we write 4 because alternate tetrahedral void. Another one is they are asking like P occupy tetrahedral void, Q occupy octahedral void, but distributed equally. They are distributed equally. For distributing equally, tetrahedral means 8 are there. There are 8 positions. Here octahedral means only 4. Now you have to distribute equally. One here, here one, here one, here one, and here one, and here one, and here one. That's why we take only 4 are for tetrahedral and 4 are for octahedral. For this position, how can we write? P is distributed in tetrahedral and octahedral equally. For equal distribution, so it is taken as P4 plus 4. That means P8. By following these tricks, we can solve. One more is they are saying A occupy tetrahedral void, but 1/3 is empty. What do you mean by 1/3 empty? Therefore, A is occupying 2/3 occupied. 2/3 occupied. That means 2/3 of TV. That means A into 2/3 into for TV we write 8 positions. 8 positions. By following these tricks, we can solve the problems. We can solve the formula of the solid state compounds. Now I am going for the example. I repeat once again. Tell me, for body center there is 1 and average 1. Face center 6 are there and we take 6 into 1 by 2. For corner 8 are there 1 by 8. For edge center we are taking 12 into 1 by 4. For FCC, HCP, CCP arrangement you take as 4. Whereas for tetrahedral 2 into 4. For octahedral you take 1 into 4. By following this one we can solve the problem. Now the first problem is a compound made with X and Y. X occupy face center and Y occupy the body center. So what is the formula of the compound? Tell me. For face center we write 6 into 1 by 2. For body center means only 1. So this become x3 y1. This is one problem. Second problem, that is a compound in a compound P occupy HCP arrangement and Q occupy 2/3 of tetrahedral void. Now what is the formula? HCP and Q is occupying 2/3 of TV. I told you for HCP deadly you take 4 and for tetrahedral 2/3 into here tetrahedral we are taking 2 into 4. On simplification what we are getting? P1 Q 4/3. On cross multiplication we get so 1 into 3 Q 4 into 1. So what is the formula? P3 Q4 is the formula. Another example I am saying. Another example is, let us suppose a compound has X occupying FCC arrangement, Y occupy corner, Y occupy the corner, Y from one position missing, then what we write here? FCC means Y is here corner we are taking, this is the data given. Now FCC means deadly 4, corner means 8 into 1/8, but they told what? Y is missing from one position. For missing of one position we take, 8 is not taken, we take only 7. The formula become x4 y 7/8. Now you make cross multiplication. On cross multiplication what we are getting? So we are getting x4 into 8 and y 7 into 1. X 32 and y 7. Thus the formula is calculated. Okay. Now this time we are taking one more example. They are saying a compound in which 1/3 of A are occupied by tetrahedral and B occupies face center. What is the formula of the compound? A is occupying 1/3 the TV and B is occupying the face center. A 1/3 into 8 here, face center means 6 into 1/2. So on simplification we get A 8/3, B is 3/1 on simplification. Now cross multiplication we get A 8, B 3 into 3. That is nothing but A 8, B 9 is the formula of the compound. So thus the problems are calculated. One more problem, that is, let us suppose in a compound X occupying edge center, whereas Y occupy FCC arrangement. For here X are missing from X are removed from one direction. They are removed from one direction. Then what is the formula? Actually edge center means we write 12 into 1/4. Here Y FCC means we take 4 deadly. Now edge center, there are 3 edge centers, X, Y, Z. So in each one 4 edge centers are there. Now one direction are removed. That's why we don't write 12. Instead of that one we write what? 8. 8 1/4 Y4. So X2 Y4 is the formula of the compound. Thus the problems are solved. The problems are solved by knowing these values. I hope you understood the method of solving the formula of the solid state crystals. Thank you.